Okay, we've got a case that's freezing product. Let's figure it out. Okay, of course, as always, we're going to examine the airflow on it, and we actually found that this one over here has bad airflow. So we see this one right here, D32, D31, D33. This one is 37. So a lot of times what happens is when you have these cases that are freezing product, the issue is actually with the case that's the highest temperature, because all those cases are in a lineup together. So refrigeration is on for all of those. They're all getting refrigerant, so the other ones will actually pull down too cold, where this one won't get cold enough, and the system's trying to get that average to be where it needs to go, and then you have these cases that are going below freezing. So first off, you know, we can't just accept that to be true. We're gonna have to go and we're gonna have to verify that temperature probe. Now, just a quick look, the rack pressure is acceptable. A quick look, the condenser's a little high, but the condensers at the store are kind of terrible, so it is what it is. Yeah, it's a little bit high, but it's a warmer day. Condensers at the store is not the best, it is what it is. So it's the best we can do. So we're gonna go up there, we're gonna verify the temperature probe. I put it in a cup of warm water. You see that's 96 degrees, so we know that that is the proper temperature probe. The reason I did that was the labeling upstairs is different than the labeling downstairs. So now I know this is the right probe, because if I put in a cup of ice water, right, it's gonna be 34 degrees, and then how do I know that the system just didn't? Well, 33 degrees, you know, ice freezes at 32 degrees. So put in a cup of water, about a degree warmer because there's water in there mixed in. It's gonna be about 33, maybe 32.5 degrees, okay? So how do I know that the case just didn't pull down the temperature? Because the case is targeting 32. So I, you know, put it in a cup of hot water so I can identify that, yes, that is indeed the probe that I need to make sure is reading accurately. Cup of ice water. All right, just to show you, so I put in a cup of ice water, and I actually was reading off by about 2 degrees. So I went to service and I offset it by 2 degrees. Now, I wish I could have shown you it. I had to use my phone for something else, so I couldn't exactly show you, but I put it in. It was reading basically 36.5 in a cup of ice water. So I minused, let me see what I put in the offset, 2.3 degrees. So I got that down to 32.5 degrees, which I thought was like acceptable for it. Now from here, I just went over to the rack really quick. I just kind of checked it, gave it a once over. I saw that it's kind of hot. I checked my rack. I have a receiver level. The sight glass was all right. Now I'm gonna head back up because I have one more angle I can kind of go on this thing. I think ends up being the issue. Now I know it's this case. I know that temperature probe is right. I'm gonna look in here, check quick. All the fans are actually fine. They're all working okay. And if I actually take like my temperature probe, just an AR gun, again just a tool. I just kind of go around here. I can see that this is refrigerating okay. This is all right. Like, this is doing just fine. Specifically up here, the airflow is just weak. If I take this, it seems to be at a relatively okay temperature, so it's weak. So one thing, this is a good tip on a lot of these produce medium temp cases, the coils, the honeycomb, they'll get plugged with like mold. So let's take a look. Now, I could be wrong, but I think there's an issue. So what's happening is the airflow is blocking on this case, which is causing this temperature probe to read that this case is warmer than what it is. So the refrigeration stays on because it brings the average of the system higher, causing it to pull down below freezing on those other sides. Because I guess I didn't mention it, I should have shown it. This is a suction stop system. So it means that the case will pull down to whatever suction pressure it is. So doesn't have an EPR, so it can get below freezing whenever the suction pressure goes below freezing. So as the compressors cycle and try to keep up with everything, it'll go down below freezing the product. But now when we clean these, it'll bring this back down, and the average will be more consistent, and all the other cases will be more consistent, and it should solve our issue. So we're gonna go to the janitor's closet, clean these up. Clean them up, put them back, and then we're gonna look at the controller. Okay, so now if we can see, right, the D3 that we just did is at 33 degrees. That's pretty good. So now we can look and we can see, you know, 34, 32, 33, 35, 32, 31. you can see that they're all so much closer than they were before. As before, I can't remember exactly, but D5 I think was 29. This one was 29. This one was 29. And so now they're all in the 30s. So it's already starting to correct itself. I think that that'll be good to go. I might take off that 35 honeycomb, check it too. Maybe I'll clean that. But anyway, so that's it. That's what was going on with it. Hope you learned something today. Please like, subscribe, and everything. And yeah, till the next time. That's how you do it.